and welcome to RJ Academy. And today, we will study Class 10 Chemistry, specifically the chapter on chemical reactions and equations. I'm going to be your helpful guide through this, basically acting as your personal study partner to help you completely crush your big test. I've gone through all the material and condensed it into the ultimate high-yield study guide for you, focusing exactly on the concepts that examiners absolutely love to test. So let's get into it. Here is our quick game plan for this explainer. We'll cover the basics and characteristics, master those tricky valencies fast, learn to balance equations, break down the 4 reaction types, tackle endo, exo, and redox, and finish up with some rapid-fire balancing practice. All right, Section 1, Basics and Key Characteristics. Let's figure out what a reaction actually is. Okay, let's really dive into this. A chemical change simply means the initial substance transforms into something completely new. Think about a candle for a second. Melting the wax, well, that's just a physical change, right? It's still wax, it's just liquid now. But the actual burning of the candle's wick, that is a permanent chemical change, specifically combustion. The properties of that wick are completely altered forever. Now, examiners absolutely love to test how you identify a chemical reaction. It's a super high-priority concept, so you need to memorize this 5-point checklist to instantly recognize when a reaction has actually occurred. If you see a sudden change in color, a temperature spike or drop, a change in state, bubbles, which means a gas is evolving, or a cloudy solid forming at the bottom called a precipitate, well, you know for sure a chemical reaction just happened. Moving on to Section 2. Master element valencies fast. You know, before writing any equations, you absolutely have to know your element valencies, and this is where so many students lose easy marks. But we can use this simple, catchy mnemonic table to lock down those tricky charges in literally seconds. For the +1 valency elements, sodium, potassium, silver, and copper, just think na kaho agar cute. For the +2 elements, magnesium, calcium, zinc, iron, the story continues with mange cars and Ferrari. And for +3, aluminum and iron, just remember Al Ferrari. I know it's a completely silly little story about cars, but I promise you, in the middle of a stressful exam, this trick is a total lifesaver. Section 3. How to balance equations to satisfy the law of conservation of mass. So the crucial takeaway here is to use this foolproof step-by-step table method so you never get lost just guessing random numbers. Always draw a table. Reactants on the left, products on the right. List out every single element. If you have 2 hydrogens on the left, you absolutely must have 2 on the right. Start from the top element, multiply the coefficients, those big numbers in front of the molecules, and adjust your table until both sides perfectly match. And hey, quick teacher tip here. Never ever change the small subscript numbers. Only change the big coefficients. All right, Section 4, the 4 reaction types. Let's look at some key exam concepts. Let's look at combination reactions first, where 2 reactants combine into one single product. This specific experiment, it is an absolute favorite for examiners. You are almost guaranteed to see it on a test. The question is, why must we aggressively rub a magnesium ribbon clean before we burn it in the air? The answer is actually pretty simple, but you have to be specific. Magnesium reacts with oxygen in the air over time to form a dull, protective layer of magnesium oxide. You have to scrub that layer off so the pure metal underneath can react. And listen closely. The key phrase you need to write down for full marks here is that it burns with a white, dazzling flame, leaving behind a white ash. Don't forget that phrase. Okay, before we look at displacement reactions, let's quickly define a catalyst. Think of a catalyst like the Mintalol homewrecker analogy. Imagine a perfectly happy couple, and this guy Mintalol comes in, whispers some rumors, causes a massive breakup, and then just walks away completely fine. A catalyst enters a chemical situation, causes the reaction to happen much, much faster, and then leaves completely unchanged. It doesn't get consumed at all. And that brilliantly brings us to the reactivity series for displacement reactions. In displacement, a stronger, more reactive element kicks out a weaker one. But how are you supposed to remember the exact order? Well, here is another amazing story mnemonic for you. Katrina ne Carmangi Alto Zen Ferrari, Perbihai Q Milli Silverati. This literally maps perfectly from the highly reactive potassium and sodium all the way down the list to the least reactive silver and gold. Memorize that one sentence and you'll always know which element has the power to displace another. Now, what about double displacement reactions? This is kind of like 2 IPL cricket teams deciding to just swap their star players at the exact same time. The ions exchange places, and when this happens, you often form a precipitate. As a quick reminder, this is an insoluble solid that just falls out of the liquid and settles at the bottom. A super famous example is mixing colorless lead nitrate with colorless potassium iodide. They react to instantly form a bright yellow precipitate of lead iodide. Let's look at one more highly tested exam question. This one focuses on a very specific type of decomposition reaction, which is basically when one reactant breaks down into multiple products. So why do we always keep silver chloride stored in dark black bottles in the chemistry lab? The answer is that light actually acts as the energy source here. You must specify in your exam answer that light causes photolytic decomposition. If regular sunlight hits that white silver chloride powder, it breaks the chemical bonds, releasing chlorine gas and leaving behind bare gray silver. Fun fact for you, this exact chemical reaction is what made old-school black and white photography actually work. Section 5. Endo, exo, and redox. Let's talk about energy and oxygen transfer. Here's a really great comparison chart to copy into your notes. Exo means out, so exothermic reactions release heat outwards. Endo means in, meaning endothermic reactions absorb heat or energy inwards. Examiners love to test real-world examples of this. Remember that human respiration releases energy, which is why it's exothermic. But plant photosynthesis? It has to absorb sunlight to work, so it's endothermic. Finally, we have redox reactions. This is simply when oxidation, which is gaining oxygen, and reduction, which is losing oxygen, happen at the exact same time in a single reaction. The ultimate exam hack here is a mental flip. The substance that gets oxidized is actually acting as the reducing agent. And the substance that gets reduced, well, that is your oxidizing agent. Just reverse the roles in your head and you'll never get those tricky multiple choice questions wrong. Section 6, Rapid Fire Balancing Practice. Time to test your skills. Okay, I want you to pause this explainer right now. Grab a pen and use our step-by-step table method to balance these 5 classic equations yourself before looking at the answers. Notice how we use the coefficients to make sure the left side perfectly mirrors the right side. And hey, pay really close attention to the bottom 2 equations. Examiners sometimes throw in equations that are already perfectly balanced just to test your confidence and see if you'll second-guess yourself. Don't fall for the trap. So before you wrap up your studying today, I want to leave you with one final, kind of mind-bending thought to ponder. If breaking a chemical bond requires energy, but forming a new one releases it, what truly determines if a reaction will explode with intense heat or freeze your beaker solid? Think about the delicate balance of those energies. It's like a microscopic tug-of-war. Notes of this chapter is in the description. Catch you next time.